Just another quick live. Had to make some adjustments to the Crucifix for the 3D printing project to get a bit more accuracy in the measurements. So thought might as well just live stream that. It's only a quick, well, it should be only a quick stream, but we'll see. Right, so got to, when you set up your Blender for printing, you don't necessarily need to alter the units so long as you have your length set to millimeters, because this left as is, well, if this is adjusted, it adjusts the scale of the object on export, which is what we found the other day, or the previous video, when we were exporting and importing the meshes into the slicer. They imported very small because they were being rescaled by the value that had been set as the unit scale. So if we just leave this as 1, it should correspond to 1:1 with our mesh when we import it. So the Crucifix is where's the N key? So the Crucifix is 60 millimeters high. So we want to maintain that. Well, that's a 6,000 millimeters, but it's actually 60 millimeters. So this may differ depending on which version of Blender you're using. Scale. So we can change. Can we change the scale? 0.01. No, it's not that. So this is the problem with 3D printing and trying to get our values relative to the scaling that the printer uses. And the printer in this case uses millimeters, but so this is a disparity. We can leave the settings and the properties on their defaults, but just change the length. But when we import that into the slicer, it's going to import smaller because that scale or that measurement is relative to unit scale. So if we leave that as what it was, which was 0.01, that's millimeters, which then means our dimensions are correct in Blender, but not in the slicer. So we may have to juggle between the settings being correct relative to the dimensions that we need for the 3D printer versus what we need in order to get a functional mesh out of Blender or within Blender whilst we're working on the object. And this is why, if we leave this as is, so that everything in Blender is set up relative to millimeters and we get proper units of measurement. So this is 60 millimeters high, or 6 centimeters. It gets really confusing, but when we export this mesh from Blender, we can use the upscaling that's available for the export process and upscale it by 10 times, and that gives us our correct scaling in the printer. So this is where it gets really confusing because of the way that Blender works with units of measurements versus other applications. So if this was made in 3D Studio Max or Maya or something else, we might not get exactly the same problem, or a CAD CAM, for example. But that's a long way to say a bit of fiddling to be done. View, let's get that centered. Center. Let's just go with 60. I want to add a cube. going to be massive. So let's just rescale that. So that defaults the cube to its default scaling relative to Blender. So the default cube is 2 units by 2 units. So because we've altered the units of measurement, it's absolutely massive relative to what we're working on. So let's go with 20 by 20. What we actually need in this particular instance is that to be 8 by 8 by 8. Hold Control, snap to the grid, and move that up, because what we're looking for is making sure that the top of this doesn't poke out of the top of or above this. So this is 8 millimeters from the top of the crucifix, but we want our measurements to be relatively precise. So select that, press G, Z, lock the axes, just move that down. And that's zooming all the way in to as far as we can go. That's that one, and it doesn't matter that we've got a little bit of intersection here because we can use that to our advantage. So that's that one. That's the other one, so that's quite small. So edit mode. Vertex select. Move that up. Same again, zoom right in. G to move, Z to lock the axis, and move that up. Hide the cube. Let's just call it 8 by 8. Hide. So that's the loop. That's loop 1. That's loop 2. That looks about right. Save. Save as. Oh no, save increment. There was something else that needed to be done, but I can't remember what it was. So that one was 40 millimeters. Yeah, so this is the problem with the unit of measurement set up the way that it is, because so what we have to do is match the scaling in scale, grid scale, so 0.01 and we get our, so that'll be a centimeter, so that's 10 millimeters. Right, so let's close that hole. Edit mode, Control plus, Control minus, delete. Edge select, loop select, so that's Alt click, and then press F to fill that hole. And then what we can do, object mode, is duplicate that, so Shift D, drop that down, and then rescale this. So now it's going to rescale relative to the origin point. So what we probably want to do here is use that top face that we just filled, snap the cursor to it. So that is select. Is it select? Or is it snap? It's snap. Cursor to selected. Exit. Select our object we want to scale, and then set the pivot to 3D cursor. Whoops. So set that to 3D cursor, and then we can scale it relative to that point. So, whoops, wrong one. So uniform scale, hold control. Hmm, 7.5. Okay, that's going to be a bit close. That's a bit too close to the edge. So let's use our properties. So it's kind of tricky to try and determine the size of an object when we've got 0.5 of a millimeter and all of that decimal place stuff. So it's easier just to use scaling. So what we can do here is, let's try the X, set that to 6.5. Is that too narrow? That's too narrow. Okay, 7.5, 7. We don't need to reduce this to 7. Whoops, undo. Why did that do that? Not relative to. Right, so this is where it's a little tricky sometimes, because even though we have the 3D cursor set as our pivot point, when we scale our objects, it's going to scale it relative to the origin if we are using the scale values instead of using the widget. But obviously holding the widget down with, so that's Control with Shift, so that we get smaller increments, but it's still snapping to the grid. I think we'll leave that at 7.5. So that's that one. We want the other one now. So hide loop 2, select loop 3, duplicate, move that. 3-pick, it's Blender 3D. You can get that from blender3d.org. No, is it blender.org? No, it's blender.org. And it's completely free, so you can download it and fiddle around with it without paying anything. No subscriptions, nothing. Right, so make sure that's active. It is. So pivot, scale, hook, control, snap, 7. So we need to be aware that this size or this design works relatively well for something that's relatively large. So this is 60 millimeters. So this is basically 10 millimeters high. But reduced down to a smaller size, that hole is now going to be probably 4.5 millimeters, 4 millimeters. So that can limit your options in terms of how this, as a piece of, let's say, costume jewelry, how that's going to be usable or functional as a piece of jewelry. But so let's do Control Shift. Oops, wrong one. Select and use the, so that's much smaller. Is that because the scaling's not set? Whoops. Yeah, forgot to set the scale for that, the original. So we need to reset the scaling on this so that it's the same as the Crucifix. Don't need to do this for 3D printing, but it just makes it easier whilst you're actually working on your project in Blender, because your measurements, scale, proportions are all relative to whatever the object scale is. So object, apply, rotation and scale. So if we put this back to 0.8, this will return it back to its original size. We can then apply scale, apply rotation scale, and then rescale it. 0.7. And now, of course, we have to move it up. Whoops. So 60 millimeters and 40 millimeters. Is it 40? Yes, 40 millimeters. Right, so save that. File, save. And then we can export. So loop crucifix file export STL. So this will be 6A. Actually, let's call that 6B. So we want to export the selected objects. So selection only. Apply modifiers, that's okay. It will apply the subdivision surface modifiers to the mesh, so we don't necessarily need to worry about that too much. Export STL. So that's the first one. Hide that, unhide that. Loop, crucifix, export STL. We'll call this one 6A. Same settings, selection only, export STL. Now to export the other one, the shorter one or the smaller one, we want to move, let's reset the pivot point back to median. Median is the default. Move this to the center because our exports are relative to grid center. That just makes it easier to organize the scene, because when they're imported into the slicer, they'll import relative to this position, so centered on the grid basically, in both the slicer and once the slicer's done its thing, centered on the print plate. So same process. So we'll call this, whoops, so loop, crucifix, file, export STL. We'll call this 6A. Is it A? Yeah, A2. Same settings. So we might have to come back to this, as we'll see, because we're leaving the scale using the default value. Export. Loop, crucifix, STL. So this is 6B2. B2, same settings, export STL. Right, so we can now open those in our slicer. Which is basically an old version of Creality or Creality. They don't make the printer anymore. It's a good printer, but 3D printer, but it's obsolete now. They've got newer versions that cost twice as much. But this is their slicing program. This is the thing that you use to prep your meshes once you've exported them from Blender. You use this program to prep them for printing. So it gives us this print volume box. So that's a representation of the available print space. And then we've got various settings and options that we can use and tools and things. And obviously we can't scrunch the app down to fit on TikTok screen size, so I have to make do. So we're going to load in the files. What do we call them? Physics declaration. So this is the STL files. Right, so there they are. So that's 6A. Can we import multiples? Oh yes, we can. Never done that before. Yes, so let's open them. See what that does. Yes, see? So, they're tiny. Teeny tiny. And that's because, as mentioned or as discussed, why is it giving us a... It shouldn't be giving us that red area. But they're tiny because the scaling is relative to, or it's been modified relative to, where is it? It's been modified because of the unit scale. So relative to how we work on our print projects in Blender, as was being discussed earlier, so this grid is now 10 millimeters by 10 millimeters, 10 millimeters, so XYZ. So each one of these is 10, which fits what we need to do in Blender, but that scaling makes the meshes disproportionately small, or this unit scale, when we import them, which is why they're tiny. So what we can do when we export is, so which one was this? This was B2. So what we can do is, instead of fiddling with unit scale and messing up the project or the scene, what we can do, whoops, export STL. So this was B2. We've got a scale option. So if we set this to 10, this will compensate for the scaling, the grid scale that we've got, or unit scale in Blender. So B2, so export STL. So that's that one. This was 6A2. So this was 6A2. Same again, scaling, selected only, scale 10, export STL. So we now need to move that back out of the way and redo the other one. So that's this one. So loop, mesh, export STL. So this is A. So same again, selected, scale 10. And that's okay. So export, hide, reveal, select. So it does get a little confusing sometimes when you've got multiple meshes and multiple projects being exported from the same file or the same project. Export STL. Right, so we should find, let's delete all of these. We should find we should be able to just re-import those STL files. A to B2. And it should, there we go, correct scaling. So those are actual size now. So all we need to do is position these on our build plate. Just rotate them all first. Position them. Yeah, you could turn these into trinkets. They'll be 3D printed. So, and they're relatively small, so 60mm or 40mm. So that's about the size of what, I can't think of a comparison, maybe a USB stick. Yeah, so about the size of a USB stick. But they're plastic, so, or they will be plastic, depending on plastic or resin, depending on the printer, 3D printer you've got. But you should be able to. Right, so I've got them roughly positioned. Slice. All sorts of colours. Whoops. Dang it. Right, preview. Right, so we have to make some positional adjustments because we don't want the printer head. Whoops, undo. Right, I have to because trying to avoid positioning them so that the print always basically prints around the center of the build plate, because that can cause burn in on the build plate where you have printing constantly going on in this area and not anywhere else on the plate. Slicing, Mark, all slicing does is this is the prep for the objects that you want to print, and all it does is essentially breaks the file down. See, move closer, look, see. It just breaks the file down into layers that correspond to the way that the 3D printer works. So each one of these layers is a slice, and the layout, or is this what we're looking at now, depends on the quality settings and any optimization settings that you might have in place or engaged to print the object, because obviously you don't necessarily want to be printing a solid block of plastic, because that would take hours and hours and you don't necessarily need it. So slicing just basically preps the file for, well, there are instructions for the printer that the printer understands in terms of how the three-dimensionality of the object translates into layerable or layerable plastic. So each one of these is a single pass of the printer head around the object. So that should be okay. But the thing we want to watch out for is what happens with our hangers, because the redesign is to provide a more robust hanger or loop than the originals, because they were prone to snapping. Where's the original? So those were prone to snapping because they were too thin. They would either break at these points or they would break somewhere along the loop or around the loop. So the new designs are just basically a test to see if we can strengthen them without necessarily doing something that looks a little weird design-wise. And this is the kind of thing that you would have to think about if you were making jewelry, costume jewelry or proper jewelry. You'd have to think about these things, because we don't necessarily... So you've got two options. You can either build this into the model itself, so the loop is part of the model, which you then cast. So you would probably create a wax positive from a silicone negative. So you'd cast this in silicone, remove it to get your negative space, which you then fill with wax, which becomes your positive, which you then surround with your plaster medium if you were going to cast this in bronze or gold or silver or whatever it is. But you've got two choices. You can either incorporate things like this into your main object, or you rely on just casting the main body of the object and then brazing or soldering on the loops, which you might purchase or cast separately. So either or. But you've got to think about these things if you're doing costume jewelry or jewelry generally. But with plastic, we have to make sure that we get as much layerable structure on the loop to give it as much strength as we can. And we've just done two designs just to see how that will play out. So this is going to take 4 hours and it will use about 10 meters of medium. Let's see if we can reduce that a little bit. That's 30 grams. So settings. Let's try 1 millimeter. 2. That should be okay. Reslice. So that change has dropped 30 minutes-ish off the print time and about 2 meters of medium off our material use. But we've still got a functional crucifix or object, but it's now just 2 layers or 2 lines of wall thickness instead of 3, because for something like this we don't necessarily need 3, because this will be stiff enough as it is on its own because of this structure inside, this optimization structure. Right, so that is going to be that. So this is a preview of what the printer will do. So that looks okay to me. So save this. Save the file. So this is version 3. That's version 3. G-code. Save. And then we'll save file, save the project. Save. Version 3. Save. So it's the G code. It's the G code which is saved here that is sent to the printer that will then print it. So if you had the time to set this printer to print these objects as solid, you could, in theory, print them as solid objects. You don't have to, but this structure is an optimization, so it's a compromise. So we don't need anything in here from an object's point of view. From the object itself, it doesn't need to have an inner element here because all that's necessary is basically the wall. But without this inner structure, you can't print the top layer because the printer can't print across a void. So you need this structure in here to give the printer some structure to be able to print across that void. Otherwise, obviously, the print just collapses on itself. And depending on how big the object is, so this build plate is about, where is it? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So it's total width is about 180 millimeters, so 18 centimeters by 18 centimeters, but you generally don't want to be printing in these border zones. So it's basically 160 millimeters by 160 millimeters. So that's your, if you were trying to print something that was that big, 160 millimeters, that, depending on the design, would take quite a while to print. So you optimize the print if it doesn't need anything inside it to reduce time and the amount of medium that's used. Because obviously, depending on the medium that you're using, it can get quite expensive for printing, even though these are custom objects that, you know, nobody else would have except you. But there's a cost. There's a cost equation that's involved, because that's just wasting medium. If you print the inside of this, it's just wasting a lot of medium. Right, so that's pretty much it. That's all we needed to do, was just to make some adjustments to this and then re-import the objects, get them prepped and laid out for the print build plate, and then the next step is to load these into the printer and let it print. Right, so that's that done. That's all that was needing to be done. So yes, all we need to do is print these out, and we'll post some screenshots and maybe capture some video if possible. Right, we'll call it quits there because this has gone on for 47 minutes. It wasn't meant to be going on this long. So thanks for lurking, lurkers, and we'll see you on the next live. Yoink.